First of all, AI is moving at an incredibly rapid pace, so it's very hard to keep up. Every decision we make now, whether to build or buy, has to be made with the focus that it's a short-term decision. We don't want to lock ourselves into a situation where we're just left behind. Would I buy an AI tool with a contract for 3 years today? Maybe not, because there is a good chance that a year from now, there's going to be new advancements. So this is where I started thinking in terms of a bridge solution. A bridge solution is not the best perfect solutions you want, but a solution that unlocks value fast. And it could be either build or buy that gives your teams time to figure out what the right solution is and whether maybe wait for a software vendor to develop one or maybe build it internally. I had a presentation years ago, Today is Tomorrow's Legacy, where everything we do today is legacy tomorrow.
Welcome to ODSC's AIX Podcast, your gateway to the latest in AI and data science. Whether you're an aspiring data scientist or a seasoned AI professional, we bring you insights from the best minds in the field, shaping the future of AI. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Sheamus McGovern, the founder of ODSC, will be your host today.
Welcome to this episode of the ODSC AI Podcast. We're joined by Veronika Durgin, VP of Data at Saks, to dive into the most neglected data engineering tasks, a topic that struck a chord at our recent ODSC East talk in Boston. With over 2 decades of experience across data engineering, architecture, and analytics, Veronika shares hard-earned insights in building resilient pipelines, defining what done really means, preparing for seasonality, and balancing technical debt with innovation. So whether you're a hands-on engineer, interested in AI, or leading a data team, this conversation is packed with practical insights, cautionary tales, and some excellent advice. Veronika, thanks for joining us.
Happy to be here.
So Veronika, you recently presented at ODSC East 2025, and your talk title was The 10 Most Neglected Data Engineering Tasks. I believe the presentation definitely struck a nerve. You talked about the unglamorous but critical work that often gets overlooked when teams are rushed to deliver the next big feature, right? We all understand that pressure. But before we get deep into this topic, can you please introduce yourself to our audience and tell us some pivotal moments in your career?
So Veronika, thank you for joining us. Thank you for listening. I've been in data forever. I kind of stopped saying how long because people try to figure out how old I am. So I've spent my entire career in data and I kind of fell into it right after my bachelor's degree. So I went to college as pre-med. So I have undergrad in biology and interesting kind of like talking about pivotal moments of my life. So I was at Northeastern at the time. Northeastern has co-op programs where you go to college for 6 months and then work for 6 months. I was working at a hospital lab. So my primary role was to actually prepare blood samples for tests. I can tell you all kinds of information you never wanted to know. But I also ended up doing data entry. And back then, we're talking about late 90s, there were dumb terminals and kind of manually written notes from doctors. And I was entering into this application, which was just very logical to me. I could navigate all the screens and stuff. And it seems that it wasn't logical to anybody else but me. I loved math. It was easy. Anything logical is easy for me, just kind of how my brain works. And they started leaning on me like, hey, can you figure this out? Can you figure that out? A woman that I worked with said her husband was looking for a computer operator. And would I be interested? I said, of course I'll be interested. My pre-med never worked out. I did end up getting a degree in biology and then just continued working, did a little bit of computer operator, got my first introduction to Microsoft Access, kind of started falling in love with data and landed in my very first junior DBA, database administrator role. And then completely fell in love with it. And I said, this is what I want to do. I get it. I love it. I want to learn more about it. At the time, there was no degrees in data, as you can imagine. So I ended up going back to college to get a master's degree in software engineering. I had never written software ever, but I loved it. And I think if I had an opportunity to become a software engineer, I would have, but I just stuck with data. But I think that degree was super helpful and useful. I learned about software development methodologies, project management, technical writing, all kinds of fun stuff. Also talking about languages like Perl. I don't know if anybody still uses it. VB.NET just came out. It was wonderful. But for me, I always followed my curiosity. The next thing that kind of piqued my interest. I would like, oh, I want to learn more about it. And that just kind of how my career worked out. I worked for the longest time with transactional databases. I focused on performance tuning optimization. So you probably see now that you rethink my presentation, a lot of that back-end optimization. And then I was done with it and I was like, all right, analytics, analytical space, what's next? So I kind of leaned into that. And so here I am.
Yeah, Veronika, I can definitely see those years of experience coming through in that presentation. I also went to Northeastern, a great STEM school. Absolutely excellent. I really loved it. For our listeners, the presentation will be available online. So we are going to actually link to your track keynote talk at ODSC East. That was a pretty short 30 minutes. So I think our listeners are going to get the benefit of a more extended session. I'm going to start with some of the ones that resonated the most, I feel, well, with me, I guess, because it's not one conversation, but I hope will resonate with our audience as well. The first one that you talked about, you presented a fascinating decision framework that goes beyond a typical build versus buy choice. And the problem with build versus buy, usually people present that as a binary choice when a lot of times it's not. And you took it a step further and you introduced what I think is a very practical approach, which is the third option, the bridge approach. Can you walk us through what that looks like in the real world and why, and especially what resonated with me in that the bridge approach? A lot of teams overlook the total cost of ownership, whether it's build or buy.
For sure. Yeah. So before we dive in, I just wanted a quick disclaimer. My opinions are my own, do not represent any present or former employers. I actually started a blog series on every kind of topic that I discuss. You can find it on Medium and get a little bit more details, specifically about build versus buy. I have build versus buy conversations. I'm sure you do, probably weekly. There's a lot of passion when you walk into that conversation. It's almost like Android versus Apple. There's just passion for one. One is not better than the other. You actually have to look at it holistically. And what I hear often from the buy side, oh, we're going to save $20,000 if we just don't buy this tool and we build our own. And I said, well, okay, great. On the surface, perhaps, but let's look at the total cost of ownership of building, like your salary, right? Person writing code, all the infrastructure. So you start peeling layers of what it would cost to build. Same with buy. Buy isn't always the right choice either. I kind of go through steps of what to consider when buying. In the past 5-10 years, is the consumption-based models of many software tools that we buy that isn't quite as flexible and scalable with the business. We kind of like encourage to buy more because we get better discounts. So then we end up buying too much and make bad decisions to use that compute or get penalized. There are all these things to consider when we try to balance build versus buy. I usually suggest that teams come up with a matrix when they evaluate something to solve a problem. And when you evaluate, it should be maybe 2-3 tools, but also including building yourself. If a problem that you're trying to solve doesn't actually deliver competitive advantage for your company, you probably shouldn't be building it. And I can throw a million examples of ingestion tools, right? Like, oh, I'm going to write my own pipelines. Why would you do that? Unless you're in the pipeline writing business where you're actually selling software. Your company doesn't benefit from you moving data from point A to point B. They benefit from you using that data to help make decisions. Now we are in the world of AI. First of all, AI is moving at an incredibly rapid pace. So it's very hard to keep up. Every decision we make now, whether build or buy, has to be made with the focus that it's a short-term decision. We don't want to lock ourselves into a situation where we're left behind. Would I buy an AI tool with a contract for 3 years today? Maybe not, because there is a good chance that a year from now, there's going to be new advancements. So this is where I started thinking in terms of the bridge solution. The bridge solution is not the best perfect solutions you want, but a solution that unlocks value fast. And it could be either build or buy that gives your teams time to figure out what the right solution is. And whether maybe wait for a software vendor to develop one or maybe build it internally. I had a presentation years ago, Today is Tomorrow's Legacy, where everything we do today is legacy tomorrow. And this is even more relevant now than ever. We think of our platforms, whatever we're building capabilities, we have to make sure that we build them in a way that they're easy to swap out. You have your core capabilities, functionality for your platform, and then you build around it, but you also need to make sure that you can easily take that component out and put something else in. Let's look at mainframes. Would you put a mainframe in place now? Probably not. And the reason why some companies still have mainframes because they're so hard to replace and they're actually dragging everyone down, right? Because they're not capable to keep up with the new tech. They're not capable to integrate. It's like, I don't know if you're an Apple fan, but if you have like iPhone, I don't know, 4.5, you're pretty much left behind. You can't upgrade software, you can't download new games, you can't do anything. So this is kind of where I think it's a mind shift. You almost always building things that are only temporary. And it's hard because you want something like you want to be proud of what you built, that it's existing forever, right? But you actually have to build with mentality that it'll probably be gone in 2-3 years. And you actually want it to be easily replaceable in 2-3 years.
Yeah, Veronika, I can see why you're writing a blog on each of these topics, because each of these points could be a podcast as well as a blog. I'll share the slides, and if you share the blogs with us, we'll publish them as they become available on Open Data Science. We'll also include a link to the show notes to your Medium so people can track it there. A couple of takeaways I had from that, and some of these are new and some of these are age old, but it's a team reality check, right? I always used to ask people that it's not can you build it, but should you build it? I do like the bridge strategy because another task later on about the business side and, walk a mile in the business's shoes. And look, a lot of times in certain industries and certain businesses, they don't want to wait for the perfect solution. They want something they can start working with now. I do some work in venture, and you can see so many examples of people acting quickly and understanding that tough trade-off between the business wanting something right now, not waiting for that solution. But I do think people really undervalue in the build versus buy debate the opportunity cost there. And then both have heavy maintenance costs. You're doing open source. A lot of times it doesn't come with security and not at layers. There's one other element that I've been pushing for the last, at least in my own tech team for the stuff that we do as one of my head of AI roles. And that is what I used to call it build versus buy. Now I'm going to say build versus buy versus bridge, but I used to say just wait, especially when it came to agentic AI and some of these very fast moving models. But you could see the trajectory, you could see where things were going. So
I've seen this, funny you say it, I'm kind of chuckling. I've seen this around a lot of platforms where struggle and spend 6 months building something, and then the platform vendor, whoever, just like, here you go. And they're like, sometimes you do need to wait for a minute. And again, because building internally that capability, unless you plan on monetizing it in a way, right? Like, is it unique to your business? Do you want to sell it? Then just wait, or maybe help your vendor partner. Because if they're focused on that, right, they'll do a much better job too if that's their primary focus when it's not yours.
Yeah, but the problem is lack of visibility into that process. But moving on here, because the second one that resonated a lot was the definition of done, which I do believe is more relevant in 2025 than any time in the past. So I think this is an age-old problem in technology. But before I give you my thoughts on it, I want to talk about your definition done. And if I recall correctly, because I did watch your presentation, I think you used that Mission Impossible saying, what's done is done when we say it's done,
Yes.
which I loved. In there, you did lay out 6 critical success criteria. You could walk through some of those criteria. It seems like painful lessons there. I think we all have some of those to share.
This is how the slide happened. If it happens more than once, there is a problem, right? How many times I've had a conversation with engineers where they're like, I'm done. What do you mean you're done? Well, code is written. Okay, is it tested? Is it accepted by others? Are there any bugs? I really wanted to write something about def complete is not the same as done. And that's how everything came together. The definition, by the way, I'm trying to come up with memes the old way, and a lot of Googling and poor designs. The definition of done that I use that I really like says that it's done when obviously all the acceptance criteria met, and also when whoever requested that feature accepts it. And it could be a human, it could be a robot, AI, a program, right? It doesn't have to be a human, it could be a machine. So meaning that just because you built it, if nobody's using it, it's not done. It's just work in progress. And the way to hold yourself honest is to list success criteria for what done really means. Done means code is completed based on requirements. And again, that's not done yet, right? Data has to be validated, not just, my code compiles. Actually validate the data. I see this so much in data engineering. I run the query, it works. But have you actually validated the quality of data you're receiving? You're receiving all data? No. Okay, no, this is not even close to being done. The other thing is downstream impact. Do you understand how whatever you're making changes to is used, who your downstream consumers. When you make a change, is it backwards compatible change? Is it not? Do you understand who you're impacting by the change you're making? SLAs, establish SLAs. Like I see this a lot. Just somebody throws something over the fence, like, oh, now it's your problem. No, 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 it's not. Let's talk about SLAs. What are the expectations from your downstream consumers? Do you guarantee this? How do you support it? Monitoring, alerting. Does it need to page me in the middle of the night if it breaks? I prefer it doesn't. Handing over to the other team, right? If you don't know who you're building this capability for, you shouldn't be working on this. And I actually tell that to my team. If you don't know why you're working on this and who needs it, ask. And if nobody can answer, you should not be working on it. So hand it over to the other teams. The code is merged. 2 months later, somebody's like, oh my God, we need this. Is it done yet? I'm like, oh, it's been done for 2 months. There needs to be a handover. And I always say, just write these down. Hopefully, some of it is automated in some shape or form, but it keeps us honest. It also
Yeah.
encourages teams to ask questions and not just take requests and work on them without really understanding how it fits into bigger picture.
Yeah, and there is a managerial and cultural question here as well, because let's just say the business stakeholders, their definition of done, even though I may say I coded this to the functional requirements and I did editorial requirements, and then all of a sudden they're coming back with scope creep. So you get these pushback. I think that legitimately is some pushback. How do you handle that?
How do I handle that? I tend to just try to engage more often. I think more frequently, maybe where, and we'll talk a little bit about, walk a mile in their shoes. We see, understand things differently, and that's perfectly okay. I think it's incremental changes and engaging more often that helps. It's not always possible. There is scope creep. And sometimes people requesting something don't really have a firm idea of what they want, what they need. So there needs to be space for back and forth. That's why I believe in agility as a mindset, not true agile, where you just deliver incremental a little bit, validate it, a little bit validate it. It's like cooking and tasting. Like, do you taste kind of as you're cooking, make sure you have enough seasoning, or do you just put a bunch of salt and then realize that it's too salty at the end?
It's a good
I
analogy.
think it's a continuous process. My mom always feels there is not enough salt, and I always feel there is. So you just have to continuously taste it, right? And engage with your users. Scope creep is interesting because, well, first of all, people will always ask for more. It's fair negotiation. Ask for more, settle for less. That's how I roll. So there is sometimes valid scope creep. Other times because the requirements were vague and the person didn't really know for sure. So I think to me that's can be solved via iterations.
Yeah, no, I think that's solid. And that was another point you had in your slides. And I think it was number 10, walk a mile in their shoes, which you mentioned. Because I do believe it's very important to have both empathy and understanding. And I think we all understand that listening is key rather than just a knee-jerk response. What's the phrase I sometimes tell people? Becoming your own customer and making engineering more approachable to the end user, because we are trying to democratize access to this. And we see now with vibe coding and other vibe initiatives that it's creeping in here. So walk a mile in your shoes. If you can brief us on your points there, what advice do you have for data engineers who want to build better business relationships? The advice you just offered was very tangible, like keep the conversations open and transparent.
I don't remember if I had a time to mention this or not, but I've read this amazing book. I think it was called Digital Mindset. Sidel Neely, who teaches at Harvard Business School. What really resonated with me in that book, outside of adopting digital mindset, is that she said that for anyone to be able to have a conversation in foreign language, you need to understand 30% of the words. So there's like 10,000 words in like English language, and you need to know like 3,000 of them to sit at the table and have a conversation. To me, that is just such a great visual as an engineer to have a conversation with somebody who is not an engineer. We need to understand 30% of each other's vocabulary. And the only way to do that is to sit together and have a conversation. Why it also resonated with me is because English is not my first language. I remember when I first started speaking in English, somebody on the other side was patient, correcting me, saying, hey, you didn't say this word correctly, or the sentence didn't make sense, or this is how you do it. Having continuous conversation. When we come together, and Gen AI is such a great example, it's new to everyone. We're all trying to figuring this together. So when the business user comes to you and says, do this, maybe we'll start on that path, but we won't necessarily get there, or maybe it's the wrong direction, and we're learning together. I think just being on the journey together. And I do this often with my teams, whatever they create, design, produce, I use. I'm like, if I can't figure this out, chances are nobody else will. So use what you're producing, use each other's stuff. It'll help us figure out how to get better.
Few phrases come to mind: eat the dog food, drink the Kool-Aids. But it's
Champagne, drink your own champagne. Let's be
yeah,
classy.
that's right. Champagne moments when it's done. You tied up all loose ends. I spend a lot of time emphasizing domain expertise to engineers. A lot of people understand that, but few fail to see the product because it does astound. But when someone's building a dashboard with lots of data points, within minutes, the business users like, what about this? They can spot bugs straight away, which the engineer or the QA person missed. So it really speaks to that. And I think that taking time to make, as you mentioned in your slides, make data approachable, teach the language of data, and understand the business terms. So that was very sage advice, Veronika. Another one I found very interesting was, I think a lot of our listeners and those just approaching the field, but a lot of people who have been practitioners for a while, healthcare, finance, retail, we definitely deal with seasonality. I remember when I did some consulting projects in healthcare down the street here in Boston. Oh my God, this is before COVID, but flu season and things like that, it was so hard to deal with. In finance, a lot of people don't realize that, but summer financial trading gets pretty dead. There's ebbs and flows, January, a quarterly portfolio rebalancing when there's a change in the S&P. So there's a lot of these peaks and valleys in platform usage, none better than the seasonality of retail, where you have, sometimes it can be high as like half the sales for the year done at Christmas, if not more. And we have 4th of July coming up. So we talk about business seasonality, because I think that's a place where a lot of engineers get caught out. They sometimes assume a steady state, so to speak. The other thing I liked about your seasonality definition was understanding it doesn't have to be predictable. A lot of it is, but there are fluctuations caused by external factors that do occur in a predictable schedule around the same time each year, but there are also fluctuations caused by external factors that are not in a predictable schedule. Look at a supply chain chaos that resulted from tariffs that were announced a couple of months ago. If you could speak to business seasonality, I think that was a great point you brought up.
Yeah, so that's another one that's been running into all the time. People get surprised for some reason. Retail is a great example. In the US, like that Thanksgiving week plus maybe a week before Christmas for all the late shoppers. Throughout my career, I worked for .coms, so that holiday season is a known thing for different companies. Like sometimes it's around 4th of July, there are like all these kind of like spikes. And then I worked briefly for an agriculture technology company, and knowing about seasonality, planting and harvesting was a shock to me. I was surprised. Planting and harvesting are flexible.
Yes, the weather. Right.
They have calendars, but it was such a critical time for the farmers, where seasonality really all it has to do is this is the most critical time for a company where they can't afford downtime. And because it's the highest volume, or it's the most critical, or it's just a time a company can absolutely not afford any downtime, and everything has to be very smooth. How it translates to engineers is you cannot touch anything. You cannot deploy to production. You can't even look at it. Everybody's just kind of sitting ready to fix should anything break. Engineers get caught off guard by that because we have our sprints, we have our squads, and we continue working. For example, the example that I used is Chinese restaurants on New Year's Eve. It's a tradition to order Chinese food on New Year's Eve. If you observe how Chinese restaurants operate, it's so streamlined. They're focused on volume. They reduce variety. They close their dining rooms. What it means for data teams is a few things. One, we need to make sure that our data ops, our ML ops, whatever that may be, processes can enable us to continue doing development and testing, but not actually deploy into production. So if you're in true CI/CD environment where you roll code to production multiple times a day, that's a problem, because you're now accumulating all of these changes in a lower environment, which means once code freeze is lifted, you have to deploy all of that at once. So how do you do that in a smooth fashion? While development should continue happening, I wish we could all take time off. We can't. We also need to make sure that should we need to hot fix something, we can. This is like, is your framework, your ops process set up in a way that you can still be productive, but also make sure you can quickly fix something. SLAs, super important. We don't want to spend energy and time fixing things that aren't critical, but we need to fix things that are critical. If a company has downtime during the busiest time of the year, like we want to make sure we fix that issue and not some little bug that can wait until code freeze is lifted. During these times, generally, there's a lot more data flowing through our systems. Can we scale everything up so we don't run into performance issues? In the past, companies have tested for holidays. I remember when I worked for Vistaprint, we would actually take half of the web farm down. So we'll run on fewer web servers to see if we can handle
Oh,
the
that's an
load.
interesting way of doing it.
Instead of expanding it, we actually
Risky,
just kind of,
risky, but
yeah,
interesting.
but it was,
Good
I mean,
example, yeah.
so maybe see less of it because cloud is supposedly scalable. Remember that whatever company we work for, we're not unique. There are plenty of other companies in the same kind of seasonality as we are. Let's make sure that clouds, whatever zones we're in, our vendors can support should we need to increase capacity, scalability of whatever environments we're running, and then decrease them when we're done. That's my spiel around seasonality.
No, it's good. Decreasing when they're done. Scaling to me is still a tricky one because I see stuff scales up and then it doesn't scale down, including the builds.
Right.
And then
when you buy, is your vendor capable of doing these like short-term scale outs and then scale back down? So that's another thing to consider if you're working for a company that has seasonality.
Absolutely. And you mentioned a few other key terms, such as SLAs, service level agreements, which we'll talk about in a little bit, because I want to keep on this track of building robust systems. Another part you expanded on was self-recovering pipelines. This was around ETL and ELT. And I just want to remind our audience about the difference between the two, because this is why I found your slide very interesting, because ETL, extract, transform, load. A lot of people are familiar with that. Traditional approach, extract data from your sources, transform it to the right format, and then load it to destination, but it's a sequential process for the most part. Single point of failure issues, whereas ELT, extract, load, transform, flips that a little bit by first extracting and then loading the data. I think this became popular with the introduction of data warehouse and data lakes and kind of running in parallel and supposedly more flexible. You highlighted 5 key elements for building these self-recovery pipelines. Will you tell us a little bit about what specific self-recovery features have proven most valuable in your experience? How do you balance that, balancing that automation with oversight, DevOps, MLOps, DataOps, whichever ops you want to go with, oversight?
Yeah. So historically, looking at my experience, traditional ETL, you load once a day, there's a bunch of information, and then something fails and everything stops. Then you spend another day trying to reprocess everything. When we went into the world of ELT, especially when the modern data stack became a thing, right? When you extract load, you load everything into your data lake and then process data in parallel. So parallelized a lot of stuff. But what we lost in the process is this concept of high watermarking from traditional warehouse, which is only process the new stuff. Don't reprocess everything. We started running everything in parallel, which made it a lot more complicated when things broke because it wasn't sequential anymore. It kind of like the spaghetti of like, I am trying to untangle and it's very hard. So I am a true believer in self-recovery. And this comes from a background. We used to brag the best DBA is a lazy DBA, is a DBA who like automates everything and it just sits back and relaxes. And then only the most critical things just pop up. So to me, self-recovery is important, but also what I maybe didn't necessarily flag here is these modular components of functionality. I'm a true believer in extract, load, transform. Extract, load should just do extract, load. It shouldn't do transform. Transform needs to be decoupled and monitor what new data is loaded and then process it. High watermark is a great way to only process new records. It's a lot less data to process instead of constantly reloading everything, and it's at the end cheaper. The other thing is rerouting bad records. That's a pretty common data warehousing thing where if you have a bad record, the whole pipeline stops. It doesn't need to be. A better process is just whatever record is, I don't know, fails for whatever reason, reroute it to a narrow queue and just continue processing your data. And then somebody asynchronously can take a look at it. It's no longer an emergency. Nobody needs to be paged. And pipelines continue processing. Retrying. My gosh, how many times, oh, it may be timed out or maybe there was a hiccup somewhere. Just add a couple of retries. It blows my mind. Another classical thing was lack of retries, late arriving data. When something's scheduled and data arrives late, your process failed because data wasn't there. Well, add a retry in 30 minutes. Like you have a buffer when it's still okay. My whole thing is like, why do we need to get paged? Can we make it so that it self-recovers? And of course, alerting and monitoring, big on alerting and monitoring. We need to be very conservative around what is being alerted. Otherwise, alerts become noise and nothing is critical anymore. In monitoring, proactively keep an eye out on things in a very regular business hours manner so that if there is a potential problem, it's fixed ahead of time. The last one is data validation. Validate your data, check if it should be a date, and it's a string, proactively check so that things don't fail when a consumer is actually using that data.
Yeah, again, Veronika, so many good points there. I have so many stories to tell you, but I can't answer the time.
I got that feedback from when I did that presentation. There's like, I feel seen. It happens.
Yeah, I don't know how many times the usual manager thing. So something breaks. How do we make sure that this doesn't happen again? Well, put an alert and monitor first. Then it happens again. How did this happen again? Well, we created an alert and monitor, but no one was looking at the alerts. Or the retry logic is like, why didn't you put a retry in here? Put a retry in, and then all of a sudden, why is this thing looping 50 times for a retry?
That's why I was very careful. I was like, whatever buffer of what's okay.
Yeah,
Right? Like
yeah.
if your data can arrive anywhere within 3 hours, right? So then at some point it does fail. I should have probably prefixed my presentation like, it depends. And here's why it depends. Not because I'm a jerk or obnoxious, because it really does. There are situations where what I'm saying isn't applicable.
Yeah, you know you're a data engineer when you have a 2-hour conversation on what constitutes a bad record.
Yeah.
But let's move on because you did talk about data testing, and your data testing slide caught my attention because you made a crucial distinction. You break testing into 2 categories, testing with test data versus testing with production data. And I think it was very nuanced that you emphasized that production data is not the same as data in production. I'll let you speak to that because I think that was critical.
That's another interesting one. I have had a very hard time on multiple occasions explaining to software engineers or anybody with software engineering background that for data teams, we actually can't deploy anything until we test and validate with production data. There's software development lifecycle, there's lower environments, right? There's dev where you dev, and then there's A where you actually test end to end. But for data teams, we are not done until we validate data in production with production data. I also wanted to make it very clear, we actually try not to test in production. I discourage all of you from doing so. You don't want to be surprised, but this is where this slide came from. I've noticed some people just don't get it. So smaller volumes of data isn't representative of all data. We can't validate numbers. Now, even if you're training your own LLMs, if you have a small subset of fake data, you probably wouldn't want to do that, right? What you get is an output. It's probably biased. It's only a small perspective. What I'm trying to stress here is, yes, we can test in lower environments, and there's certain things we can test for our code compiles, data grain, nulls, basic referential integrity, and to add, make sure that record as it entered and the source system makes it all the way through to wherever it needs to be. But for us, for data teams, to truly say we're done, we actually have to test on a copy of production data. Do we have a way to take a snapshot of production data so that we can test whatever capability we're working on?
I think it's crucial because with different formats like synthetic data, you can do a good job of replicating production data. But at the end of the day, even outside of a QA and staging environments, it's not the same. You're not dealing with the same performance hardware, which can be problematic. And we've used synthetic data and other data formats. It tends to be a little too clean, like even something in the occurrence of null or NA or bad records. So I think that's such
it's like edge cases. You can't test performance unless you have production volume. Maybe synthetic data can be helpful in that. But again, so many times I've seen, we deployed it and just crashed in production because the volumes, the throughput was so much higher. This is like my life. As a DBA, you haven't tested performance and then holidays hit, right? You have to test regular day performance. And if you have a seasonal situation, you have to test under load. Actually, my proudest moment, I'm going to share it, is I was tasked to, we were getting 2 new database servers. One was Intel, one was AMD. That was years ago. And I was tasked to test them for performance. And I am proud to say that AMD server crashed. There was actually some firmware. They're like, no, can't possibly. I'm like, watch this happen. That was my proudest moment, that I made it crash with my performance testing.
In a test environment, not in production.
No, these were servers that were supposed to go into production. So talking about with production level loads, the server crashed and the vendor said it's not possible. It is possible because they needed to update firmware. please do test with production data, but not in production.
Yeah, and speaking of data testing, a lot of times we're testing the end product of the data and not how we transform data. You had a slide around dates and all the issues you can have around dates. I'm sure many of our listeners work with non-standard units, not just dates, but units from when you're dealing with a global database. It can drive you nuts. I did a lot of consulting in healthcare and finance and getting different data from different countries and all that kind of stuff. I think cloud computing has made it a lot easier. Like all clouds standardized to UTC, right? And I think that's absolved a lot of data engineers of bad habits. But back in the day when you see certain companies, they have to do a lot of stuff on-prem for security, stuff like that. And you'll see stuff coded in EST and PST. And then people don't understand the difference between EST and EDT. The one I just had a recent argument over was PDT, Pacific Daylight Time, and PST. So one is for summertime and one is for rest time. And when you're in Europe, it's even more confusing because when I grew up in Ireland, in UK, you've got Greenwich Mean Time. And then for summer, you got BST. So you have GMT and BST, British Summertime. And in Ireland, they use GMT in winter and then they use IST, Irish Standard Time, in summer. It's like if you can keep all that straight in your head, you're a better person than me. And then the best was I was consulting for an overseas Forex exchange. They got a bunch of money to do Forex trading with machine learning. They didn't code it on UTC. And a few years ago, they were like, we can't explain what happened at 1 o'clock in the morning. There's all these changes and the prices are all messed up. And we know the prices because foreign exchange trades 24 hours. But you know, when clocks change, they change at 2 a.m. A lot of people don't realize that 2 a.m. occurs twice on certain days if you're using standard time. So they all use 2 a.m. twice. Yeah. So they couldn't understand what was going on. I'm like, well, you're not using UTC. Sorry, we all have our horror stories.
This was like a therapeutic slide that I've seen. I want to take it a step further. While we collectively agree we should store dates in the correct data type in UTC, we should present it to business users in a clear way.
Fair enough.
Sometimes we forget, and I can tell you stories. I have this slide, right? And something I've had for a while, and we ran into this issue. We swapped source system, and one was in Eastern time, and the new one was in UTC, and we didn't do the translation for our business users. And then they were like,
ouch,
had a moment, and they were like, let's take a look. And we still missed some assets. And then we did this again. And then we just let's be precise in naming convention, at least to kind of nudge us. If we present this date to our users, and we even walked away because I work with a business primarily in Eastern time. So we say New York. We don't even say Eastern time. Make it very clear in your naming conventions what it is. We can probably spend an hour just having a pint and recounting stories around dates. Something we all know, something we constantly forget. There's so many different data types that platforms offer as well. Sometimes with offset, sometimes without offset. Just be very aware and consistent and document, please.
Yeah, I absolutely get that, Veronika. And even when you mentioned the word pints, what really galls me here, when I ask for a pint here, it's a couple of ounces short or a couple of ounces short of when I'm at home.
Trying to show my worldly whatever. I know you drink pints.
Exactly. So even the measure of what a pint is, when you ask for a pint in the US, it's slightly different from a pint you get in Ireland or the UK. But I think your first slide in your presentation was that forgotten bucket of work. As we know, there's a lot of things teams have to juggle with. We want to build out new features and capabilities, and there's unplanned work and fires to fight and all those urgent tasks that pop up. And then you have this third bucket with that big question mark, improvements and modernization. So if you can talk about that forgotten bucket of work.
So this was, again, we see it, but this was inspired. There's a very old book, The Phoenix Project. If you haven't read it, it's very therapeutic. It's around IT projects that succeed and not succeed. I cover 4 different types of work, but I summarize it in 3 because that's primarily what I see. So there's business projects of delivering new capabilities, new things. All the AI initiatives, to me, they're all business projects. They're glamorous. You get a pat on the back. We're focus on that, right? There's bugs, which we can't ignore. We have to fix it. And then what happens with the rest of work? We make a lot of trade-off decisions as we deliver. And when we have to deliver fast, we take a lot of shortcuts. That's tech debt. How often do we go back to fix it? Barely ever. It's boring, right? We have pressure to deliver on business initiatives. And organization, there's pressure to deliver on business projects. We're fighting bugs. If we don't fix tech debt, the number of bugs and breaks increases. When do we have time to innovate, to learn, to try? To me, that's like this forgotten bucket of work. And I think what I really wanted to say with that is we have to dedicate time to it and protect it. And maybe it's 30% of team's time, just dedicate it to fixing tech debt, to trying new things, experimenting with a new vendor, maybe learning more about Gen AI, maybe trying to fix something in-house. So my answer to you is how you dedicate that time is up to you. It could be a sprint. It could be a week, every other sprint. It could be every Friday. So kind of, but like stick with it. What I see is teams aligned with company priorities are really focused on business projects. And there's always this, we don't have time, but we can make it. I tell my team as a leader, I will never, ever say no if you said, hey, I'm going to spend 3 days trying something. Even if it leads to nowhere, it leads to this team member learning something new and sharing with the team. So the next time we have a problem to solve, we now have another way to solve it. Specifically around tech data, I feel like that should be a dedicated sprint every couple of months, or maybe every squad pulls in tickets for tech debt fixing into each sprint. So just make sure you dedicate a certain percentage of your team's time to this and stick with it, because that's the first one we give up when things go sideways. If you don't fix everything, just becomes very fragile. We can't add anything new because everything old is just very brittle.
Yeah, those are very excellent points. That book, The Phoenix Project, I'll include a link to the show notes because that was an interesting book because it was written as a novel because of a fictional company around DevOps, DataOps. That's a good shout out. Another point you made, you had a compelling call to action around environmental responsibility because you quoted that data centers account for something like over 3% of greenhouse emissions. And I did a little research on this myself yesterday when I was prepping for this interview. And of course, you have new projects coming out. Was it called Stargate for all the AI data centers with OpenAI and other companies getting involved in that? And, that electric composition is set to increase. And sometimes it astounds me how a lot of data engineers and AI engineers, people who work with GPUs, AI GPUs, they do not understand how much power compute, because depending if you're using a H100, an A100, or whatever chip, I'm not just trying to call out NVIDIA here, but they're running at 400 watts to 700. And I think some of the next gen chips, I think I read 6 months ago, are going to consume up to 1200 watts. And then if you're renting a rack of H100 chips from one of the AI hyperscalers, because a rack can have 8 units, you're talking about 20 kilowatts to 50 kilowatts per rack. I haven't figured it out yet, but a single run of deep research on ChatGPT is pretty expensive. And I know that's been subsidized at the moment. So I think that was a very important slide. And I think ourselves as engineers have a voice here. If you can speak to that.
Yeah. The slide is definitely outdated. I'm starting to collect more recent information when I write a blog about it. I don't know all the details. I'm worried about my kids. We are continuously building more data centers. They need more power. Our energy grids have brownouts, blackouts, power goes out. What's going to happen in 20 years? Is every free space going to be a data center? This is what I'm really like. To me, this is more at the kind of, what kind of earth are we leaving to our children? I think about it in terms of also like recycling, right? Like all the waste, all the unnecessary things we're doing because it's not right in our faces. I think we'll start competing for power because we're not caring right now. So it was more around that kind of think about the future. The side effect, it's cheaper for our companies too. Maybe that's what'll encourage us to care. But I'm thinking about it, what's going to happen to the world in 10, 20 years if we don't pay attention.
I absolutely agree. It's interesting. A lot of countries, including the US, are looking to build out nuclear power as a solution for that. It's to be seen what effect that will have. But I do believe individual engineers have a responsibility to understand what their compute costs are. And as you said, there's definitely business pressure there, which is good. But it has to be a multi-layered approach, right? There's no single solution. One question to wrap up here that was not in your slides, and maybe you could write a blog about this. I also run a boot camp for ODSC. So right now I'm prepping for our boot camp and I'm doing a course on vibe coding. And I'm also trying to do vibe data engineering, like with the ELT and ETL. When I talk to data engineers, they tend to hate vibe coding because it's like, we already deal with so much poor code that we get from other places. Are we really going to allow people to start vibe coding data feeds into our systems? And then we're going to have to deal with the repercussions. Your bonus question is going to be, maybe it's overhyped, vibe coding. Do you think data engineering is feeling the effects of vibe engineering yet, or too early to say?
I think we're starting to see it. We can't prevent it. How do you stop it? You can't. I kind of also, like everybody's going to vibe code everything because it's easy. It lowers the barrier of entry. Everybody can do it. 2 years, all of us more experienced engineers will have a job because we'll have to fix everything that was vibe coded. This isn't new, maybe a little bit bigger, faster. The modern data stack was a great example of lowering the barrier of entry for every company to do data that was both good, but also created a lot of mess. You didn't have to think, you didn't have to know. Now it's even easier. I think it's a helper. I think we'll maybe in a year or two stabilize where you can lean on it, but then you have to go through some cycle of reviews to make sure that you're not just throwing stuff into production without it being actually done with the definition of done, which is tested and works as expected and data is validated, right?
Yeah, I would say my advice would be to departments out there, hang on to your pull requests for dear life. I remember this is a kind of an old school approach, but I was working with a startup where the CEO thought they were a brilliant engineer. And he was always come in a Monday morning, hey, I coded this up in the weekend. Can we put this into production? And I asked the CTO once, the chief technology officer once, like, how do you deal with that? We just say yes. We're going to pull a pull request, but we're still waiting for pull request. He said, we'd wait until he refused it 2 or 3 times, and then we'd eventually clean it up. I don't think vibe coding is a new problem per se. It's just quicker.
It just a lot more and quicker, maybe a little bit harder to constrain. But it's an interesting one, and I'm sure you see this a lot, where anytime you're trying to implement any sort of PR or ops process, you are told you're bottleneck. So we have to, again, lots of conversation, lots of balanced trade-offs. Maybe it needs to go only to crash and burn, but in that case, have a plan B. How do you fix it if it breaks?
Exactly.
So
Yeah,
it's always, trade-offs, always trade-offs.
So Veronika, to wrap this up, any closing thoughts on these as you're writing those blogs? Anything else spring to mind over neglected tasks?
I'm hoping to hear from others as well. These are kind of like mine that's been popping up in my life more often than they should. I'm hoping to hear back from the audience to see if there is anything I missed and I should add. I'm happy to extend it or maybe remove something that maybe is no longer forgotten and that's something new.
So Veronika, to follow your work, we'll share your Medium link. We'll also share your LinkedIn. How can people give you feedback? What's the best medium for that?
LinkedIn is the social media of choice for me. So please connect, send me a message, introduce yourself, tell me if you heard this conversation or watch the recording. Let me know who you are and give me your feedback, please. Open to any types of feedback.
Yeah, Veronika, I got to say, this was educational, insightful, but a lot of fun as well. I'm sure those were a lot of painful moments for you. Those hard-won lessons. I enjoyed sharing some war stories with you as well. I'm sure our audience will find this both insightful, but also entertaining. And again, looking forward to that blog series coming out. For our listeners, please follow along and share your thoughts with Veronika. Veronika, thank you so much. And we'll see you at ODSC again.
Thank you so much for having me.
Absolutely. It was so good to have you. Thanks again, Veronika. Bye for now.
Bye.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.